Let's take a look at the Triangle Inequality Theorem. This is Lesson 1 of Unit 9. When will you teach this lesson? Let's take a look at the big picture to find out. So here's the big picture for Math 7. You can see that it's taught during the fourth 9 weeks in Unit 9, and there's 2 days given for this lesson. This lesson is also taught in Math 7 Accelerated, fourth 9 weeks, Unit 9. However, for Math 7 Accelerated, this lesson is given 1 day of instruction. So, if you're interested in those standards, helpful teacher tips, and presentation strategies, we can take a look at the scope and sequence. Just as I said before, you can see that this lesson is taught in both Math 7 and Math 7 Accelerated. In Math 7, it is Standard 18. In Math 7 Accelerated, Standard 34. Those helpful teacher tips, if you see here down towards the bottom, we're going to use the Desmos applet for Triangle Inequality Theorem. And also uncooked spaghetti or drinking straws, something similar that can be cut. And for your students, you might want to pre-cut those. I have found that when I let my students cut or break the spaghetti, most of their spaghetti lengths tend to be similar. And it's harder for them to discover this theorem because they don't have any that are either super short or super long. And so if you do let them break the spaghetti, I would make sure to give them some kind of guidance to say, make sure you have one that is 3 centimeters or less, or maybe 10 centimeters or more, something like that, so that they have some pieces that may not form a triangle. Okay, here we have the presentation strategies. And here are the 2 pages of the lesson. As you can see here, this first part, this is going to be used for either your spaghetti, your broken spaghetti pieces, uncooked, of course, or straws. And then from here on to the next page is when you're going to use the applet. So this is on the first page. I wanted to call your attention to making sure that when the students enter their information, that they put the smallest one first, then the second, then the third being the largest length. Then they can answer the question, was there a triangle formed? And if so, what type of triangle was it? Okay, right below this, it asks, what do you notice about the side links that formed the triangle? So the thing is here, if all of their pieces of spaghetti or straws or whatever they used formed triangles, you really need to push them to try a few more and maybe challenge them to see if they can come up with 3 side links that don't form a triangle. All right, so the second set of this lesson, the second half of this lesson, we're going to use the Desmos applet. But I wanted you to see where they're going to end up, because it's important for you to know that this is where we want them to end. We want them to understand, after using this applet and after having used the spaghetti, that they can add any of the 2 sides, and the sum of those 2 sides should be greater than the third. So that will be true for any 2 sides. The sum of those will be greater than the third. So now let's take a look at the applet. So I really do like this applet because it is easy to manipulate. If you notice here, AB, AC, and then C all the way up there, which is BC, and I can bring that down and make that shorter. Now we want students to play around with the lengths of the triangle. I would recommend always doing the AC as the long side, and then kind of playing around and seeing if I can take these other 2 sides to form a triangle or not. Okay, obviously these two I couldn't, so if I was looking at these side lengths, and I can change this to a whole number if I like, just to make it simple. So you can see here that if I added my two shorter sides, my 9 and my 8, that would give me 17. And 17 is not larger than 21. And we know that in order for three sides to form a triangle, the sum of any two side lengths must be greater than the third. So that's why these particular side lengths do not form triangles. Now, if I were to bump this up a little bit, let's see, let's make it about 11. Okay, now let's see if that's going to work. Now, some of you are like, well, no, Tina, because we already see here that 11 plus 8 is 19, and that's still not bigger than 21, and you would be correct. But what's nice about this applet is we can go through and we can try to, as much as we want to, we can try to make those connect. And you can see even when they lay flat on the line, they do not connect to each other. Okay, so let's make this one a little bit longer. There we go. Let's make that 15. So now when I take these two lengths and I'm going to try to, I can tell that this is definitely going to make a triangle now, and I can bring these together. You want to do your best to try to make sure that the dots line up. Let's see. There we go. Bring that one down a little bit. Anyway, so then you can see that these two sides do. And any of the two sides over here now that I add up would be greater than the third. The quickest way to check is to choose the two smallest, because of the two smallest add to give you a larger sum than the largest side, then all the other ones are going to work too. So when I take a look at this, I have 11 plus 15. That gives me 26, and 26 is larger than 21. So these three sides would form a triangle. You can use as many examples as you need, and the kids can manipulate this as often as they need to come up with the theorem about the sum of two sides being greater than the third. And anytime you have that scenario, then it's going to create a triangle.